Okay, good morning, everyone. Thanks for being here. So for the next 30 minutes, I'll try to cover about debugging PostgreSQL crashes in production. We talk about the core dumps, GDB, seg faults, and so on. So let's start by loading the presentation. And we got a crash here as well. So we have no way out from the core dumps today. We'll load the presentation in the debugger. Okay, about me. I'm Varik. I'm a software engineer with around 10 years of experience. I'm currently working at Armenia. I've previously worked at Lantern, where we are building the vector database on top of Postgres. So I have some experience on debugging the extensions and seg faults. Before going on the solution, let's talk about the problem. So imagine it's Friday night, you are waiting for a call from your friend, but instead you are getting a call from the PagerDuty that your database was crashed. So you got into a Kubernetes pod, for example, and you see that there is a segmentation fault and nothing else, and you just spend the rest of the weekend in the office trying to debug it. So the problem we are going to solve is how to make it happen to go for drinks on the Friday instead of debugging. And now let's take a brief look on the process architecture of the PostgreSQL before going forward. When the PostgreSQL process starts, it just spawns the master process, the postmaster, which then forks a new backend process, isolated backend process for each client connection. So these backend processes are isolated, but they are connected with the shared memory. And there are also background worker processes which handle the maintenance work, and also third-party extensions can register their own background workers. So with this knowledge, let's divide the crashes into parts, the handled and unhandled. What we'll call the handled crash, let's say there is a function which accepts for you to provide the positive number, but somehow you manage to provide a negative one, but that's covered by the developers. They have a if statement, and then they will throw the log error. And what happens that your current transaction will be rollbacked, and there will be no impact on the database, just a single session impact. But for unhandled cases, let's say you are using some early version of extension, then there is some memory corruption issue, and the corruption crashes the memory, and the whole postmaster should go on a recovery cycle because it cannot recover the processes. So the impact is full database restart. Also, in case of background worker crashes, there you do not have any query context, so these are much harder to debug because they are harder to reproduce in your development environment. They can be non-deterministic or dependent on the environment of the production. The happy path, let's say we got a seg fault. The happy path for us will be that we'll get the queries in the logs of the Postgres that crashed the Postgres. We'll try to run the same query on our development environment, and we'll get the same crash. So it's trivial from there that we can now attach the debugger and debug the exception and fix the bug. But the unhappy path can be that the same query would not crash in our development environment, or we won't have any query in the logs at all because of the background worker crash. So for this, we're going to use debugger. Let's talk about GDB. Who don't know, the GDB is the GNU debugger, which helps you to debug your programs. You can pause the execution and step-by-step execute the program, printing the variables and local state. To connect PostgreSQL to the GDB, we generally want to connect the backend process instead of the postmaster, because the backend process is the one which processes our queries. So we'll need to get the process ID of the backend process. There is a function pgbackend PID, which will give the current backend process PID. Then we'll attach the debugger with gdb-p to our session. And from there, we can debug, set breakpoints, and continue and call functions and examine the memory. Now let's talk about the core dumps. Imagine of the core dumps as the snapshot of the state of the program with all the things necessary to reconstruct it in the offline environment. The core dumps contain the full stack of the point of the crash, the heap memory, and the CPU registers necessary to reconstruct the state. So when loading the core dump, we have the full stack trace, the chain of the function calls until the crash, the variables, the local variables and the heap memory, and also the register state. So it will help us to debug and see where the crash would happen. To enable the core dumps, we would first remove the core dump size limit. And also it's generally useful to enable a core pattern, because without the core pattern, the core dump would just have the name of the program. But when setting a core pattern to include the timestamp and the PID of the process, we then can match from the logs the backend PID and the core dump file name. So it will be easy to know which backend crash core dump is that. Also, these commands should be done in the host environment. So if you're running inside the Docker container or Kubernetes pod, the core dump configuration should be done on the VM hosting the containers. For analyzing the core dumps, it's never difficult than attaching to a live process. The civet here is that we should provide the same binaries that produce the core dump. For example, if you are running on x64 in the production, we cannot debug with the ARM binary of the Postgres the core dump. We should have the same version of the Postgres, and then the core dump would load successfully. Also, if we have the debug symbols enabled, it's easy to substitute the paths to match the one environment that caused the crash. And then we can also go to the source files from the debugger and see on which exact line the crash happened. Also talking about the debug symbols, on the early days of developing extension, it's like useful to enable the debug symbols, because without it, you will just have the raw addresses and you would go to debug the assembly code. But with debug symbols, you can see the original function names and source line of the code that reproduce the crash. Now, for today, I have prepared a simple demo. For the demo, I took a Docker file of the Postgres 18, then added some GDB and debug symbols in it, and then I prepared a simple extension which will simulate an environment of the production crashes. There are two functions: the handled crash, which takes an integer argument, and it is deterministic function. When we call this function with an argument less than 10, nothing happens. It executes successfully. But if the argument is greater than or equal to 10, the crash would happen, the segfault. And there is also this unexpected crash function, which is non-deterministic. So in 30% of the time, there will be crash, but in other cases, there would not be a crash. So by this, we'll try to simulate a case when you have a crash in production, but you cannot simulate it in your local environment. Also, there are some scripts to set up the core dumps, as I told, setting up the core pattern, and also a watcher script that will go over the core directory, see if there is a new core file, then copy to the output directory. In your production environment, this will copy to cloud bucket instead of the local output directory, so then you can download it locally and debug. Now let's go into a VM and try the demo. I hope it would work. Here you can see I have the extension code. I'll zoom out, and then we can run the Docker compose, which will bring up our database. Now the database is up and running. Here in this next terminal, we can just run the Postgres PSQL. Here we can see we are connected to the database, and we can call our function, the handled crash, with argument 1. We can see nothing happens because here in the logic, the crash would happen if the argument is greater than or equal to 10. Now let's try calling it with 10. We can see the segfault happened and the database crashed and all the sessions were restarted. Now when we check the Postgres logs, we can see here that the client backend was terminated with signal segfault, and the failed process was running this statement. Now this is the happy path for us, because each time we run this function with the same argument, it would crash. So let's say we are trying to debug this in our development environment, then I'll open the PSQL shell again. Now we can do pg backend PID. Also, I've set up the PSQL-RC to print the PID here. It's very useful for debugging. But we call the PG backend PID. We got the PID of the backend process. Then we can just attach to it. I have prepared a small helper function to run the GDB. Now, when we attach to the process, we can see we are now attached to the process, and the process execution is stopped. Now we can continue from the debugger, and when we run the same command, which will cause a crash again, we can see that the debugger stopped here. And from the GDB, we now can go to source layout. And we can see this is the line which caused the crash. Now we can print the local variables. We can see here we have all the local variables, and from here on it's trivial to fix the crash. But let's take another example. Let's load the PSQL shell again. Now we have this another function, the unexpected crash, which is non-deterministic, which means that this one can crash in production, but we cannot reproduce the crash in our development environment. Let's run this function. So this time it survived. Then we run this multiple times, and eventually we'll get a crash. We are happy today, we are not getting. Okay. Yeah, it's we finally got the crash. And we can see our core dump voucher script detected the core dump and copied it over here. So let's say now this crash was happened in production and we are in our development environment. So I'll close the PSQL shell. Then we can load this core dump like this. We provide the binary to GDB. Here you can see the GDB script I wrote. Sorry. Attached. You can see I'm just running GDB and providing the Postgres binary in the core file. So now let's do it. Let me copy the core file. Here we can see we loaded the core file. It's like debugging live process. And also from here we can do layout src as I have debug symbols enabled. And it will point the line which caused the crash. So instead of just the stale log of segfault, we now have the very useful information about our environment, which can help us to see what went wrong, and we can print the variables and stuff like everything that was possible in the live debugging process. This is for the demo. Let's go back to our presentation. Now to recap, how would this map to the actual production use case? We have a crash in our container or pod or somewhere the Postgres was running. Then our script, the bash script or some helper script you wrote, detects the core file. It uploads the core file to our cloud bucket. Then from there, we also send an alert to PagerDuty or some incident management tool. Then you get the alert and you have your local environment ready to debug. You download the core file, load in GDB, and now from here you can just see where the crash happened, and it's very trivial from here to fix the issues. Now I'll tell a story from my experience. I call this 5-day crash mystery. So while I was working on Lantern, I got a crash. Then the pod would just restart, and I have the similar setup to upload the core files and detect the core files. Then I noticed the pattern that the crash would happen at exactly 5 days after the crash. So I could predict the next crash when it would happen. Then I tried to disable the extension, so I thought maybe I did something wrong there, but the crash still remained. Then I spun up the VM to debug the core file. Then I started looking at the core file, debugging it, and I found out that it was coming from some bash function. This was the function that caused the crash. I had the function to watch for the core files and upload them. Then I wrote it in recursion. Then in Linux, there was a 8 kilobyte stack limit. And after 5 days, the stack was filling up, and it was crashing with Stack Overflow. So this was a lesson for me to be very careful about the script that I run alongside with the Postgres, because the script I wrote to help me debug was actually crashing the Postgres application. That's my story. To recap, the key takeaways can be that in the early days of extension development, it's really beneficial to deploy with the debug symbols. Enabling core dumps can help to have some context about the segfaults and memory issues, and also having a dev environment ready for analyzing the cores can save a lot of time during the incident. That's it for today. Thank you. You can ask your questions until the elephant is not hungry.
Yeah, thanks for the presentation. And actually, what was doing your script which causing a crash for the Postgre?
I can show the code here. It was just a recursion function in bash. Because it was run from the same entry point the PostgreSQL process was taking over. The script was just calling it itself, the function, and then it was Stack Overflow. The postmaster thought that it was its child process that crashed, and then it terminates all the connection.
Okay, got it. So it's the same process, and that's why it's like it's killed and it's killing also. Okay, good. Thanks.
Thank you.
First off, any talk that uses GDB is good, just without a question. I think the cool thing for me that I've learned is when you said have the test infrastructure set up. Because I can't tell how many times like something goes wrong and you're like, how do I do this, right? And you're scrambling around and you kind of knew it was going to happen, but you didn't really prepare like a script that you could look at. I even get to the point where I actually print it on a piece of paper, or I have it up in a Google Drive that I can go to it like at any time. Because when this happens, you're not going to be ready for it. And the idea of having it set up so you know you're ready for it, I think is because it takes a lot of the stress out and you can focus on the problem.
Yeah. Yeah, thank you. Yeah, that's very correct. I learned it in a hard way. I didn't have the environment ready, then spent an hours, and then I know that it's good to have it ready.
Yeah. So any experience with debugging, not debugging, let's say troubleshooting performance issues like creating flame graphs or things like this for the Postgre? Yeah, from your experience, yes.
Okay. So like performance issues, right?
Yeah, performance issues, yes.
Actually, I have
like low-level performance issue, not like query plan and things like this. Yes.
Okay, I did some performance benchmark back in there. I mostly used perf to the built-in perf in the Linux to run the process under perf with some stress testing, and then I was looking through the flame graph, seeing what functions were like taking the most of the time, and then digging up deeper in the code. So I will not say that I have very extensive experience with that, but the perf was the one tool I was using for performance testing there.
Okay, and interesting stories like insight you found like using flame graph or just?
Yeah. There was an issue. Our vector database needed to use the SIMD instructions. But for some reason, I felt like it was not using them. Then I do a perf. Then from analyzing the flame graph, as I remember, I found out that there was some mutexes blocking each other rather than the SIMD not being used.
Okay, great. Thanks a lot. Yeah.
Thank you.
One monitoring story that I thought was kind of interesting was that I have a lot of equipment at home and I do pings every night, just to make sure everything's working. And I starting to get pings on, like a failure on one device. And it was like intermittent. And all of a sudden my wife walks in one day and she said, the laptop in the kitchen's acting funny. I'm like, oh, I said, I've been getting failures on that device. I said, I know it's the Mocha card that converts Ethernet to coax. I said, I'm going to order new ones from Amazon and replace them all because they were all 12 years old. But I felt like a genius, She walked in, she said, something's a little funny. And I'm like, I know exactly what it is. That's when you really won.
Yeah.